Okay, this goes over homework 7, the prescriptive analytics problems, where we have a pricing problem, a knapsack, and an assignment problem. The pricing problem, you have to create decision variables. So what I did is I copied these down to right here and just got the values. These become how much you make. So these become variables we want solver to have control over, as well as the pricing. So I put in numbers here. Then I wrote demand functions. I wrote a demand function that was this first one, so 1600 minus 100 times the price of car 1 plus 4 times the price of car 2. I wrote another one there unique to car 2. I wrote one for car 3. These are all demand functions as a function of price. Once I have that, then I had to, the amount made is just the sum of those. And then I also wrote a formula that calculates the average miles per gallon for the fleet. And I can do that by taking the sum product of my miles per gallon, which is an input, multiplied by the produced, and then that divided by the sum of produced will give me the average miles per gallon. So I need to write constraints that say this needs to be greater than this needs to be equal to this, and then my profit function is my revenue, which is my price times what I produce, minus my cost, which is the amount of cars I make times the cost of those. So the solver model looks like this, where I'm trying to maximize this. Now this is an odd thing with solver, is that you only can choose the cells that have decision variables. If you choose other cells, it'll drop a number in there. So that's a little bit weird that solver does. So I only pick specific cells. You can see I took B8 through C8, so these two, and then C9, and then D9. So I just, it's just picking and choosing specific cells. But that also includes cells B16 through B18. The B11 through F11 is the amount that we make has to be less than capacity. The CAFE restrictions, my produced CAFE has to be greater than requirement, and then my produce has to be equal to demand. I mess with this a little bit. I don't know if you can say, I don't think it works well if it's greater than, unless you do something and restricts the price of this. The other thing, since you're using a nonlinear model, you probably ought to go over on this and use multi-start. Well, I don't know if you have to, if you do that, you're going to have to put bounds on your variables. So I didn't use that. Anyway, when you solve it, that's the answer I'm getting. You can see the big car is more expensive than the little car, the middle car, which is more expensive than the little car. It's not using plant E at all. You can see what it's producing, and then this particular fleet, and that's maximizing my profit. For this problem, you've got to create a binary variable, a yes/no variable, for each of the investments. And this is the cash required, so the cash used is the sum product of this against the yes/no variables, and then my NPV is the sum product of my NPV against my yes/no variables. So I'm going to open up solver, and what I'm trying to do is take this value, trying to maximize it by changing these 7 variables, and then I need to add a constraint that the budget the cash used has to be less than or equal to the budget, and all of these have to be binaries, like that. And this is a linear model, and when you solve it, there's the answer. It chooses to use cells 2, 3, and 4, and 7, and there's your NPV. It doesn't use everything. So now after that, I want you to write constraints and then resolve it. And I'm really just focusing on, can you write constraints? And so the first one is solve, assuming that at most two of investments 1 through 5. So at the most 2 of these. So the sum of these has to be less than or equal to 2. So I'm going to think of it as left-hand side, right-hand side. On my left-hand side is the sum of these 5 investments. And I know that they need to be less than or equal to 2. At most 2 of those. So you can't have more than that. So I'm going to go to solver and I'm going to add, and I'm going to say this has to be less than or equal to this. There's my left-hand side, right-hand side. And I solve that. I get a slightly different answer where I use at most 2 of the 5, so that there's that. And then we'll turn that one off. Turn that one off, which is this. I'm just going to delete it. Now I'm going to do the next one. Solve assuming that if investment 3 is selected, if that's selected, then investment 1 must be selected. So think about what that means, is that this number only can be 1 if this is 1. Now that can be 1 by itself, but this number can never be 1 unless this is 1. So this always needs to be less than or equal to this number. So my left-hand side is this, and that needs to be less than or equal to my right-hand side, that. Oops, sorry. So my left-hand side is this. If this is selected, then investment 1. So I can select 1 on its own. This doesn't restrict me from selecting 1 on its own. It restricts me that if I select this one, then that has to be 1. So 3 has to always be less than or equal to 1. And again, I could go back to solver and add that constraint. This needs to be less than or equal to this. And I could solve it. And sure enough, it doesn't choose this, but the purpose of this is for you to write these constraints, be able to know this. And then the last one, so I'm going to go back to solver and turn that one off. And then the last one is solve assuming that at least one of investments 1 and 2 must be selected. At least one. So at least one of these. So that means that the sum of these must be greater than or equal to 1. So there's my right-hand side, and this is the sum of these 2. And that needs to be, greater than or equal to. Same thing, I'd open up solver and add a constraint saying that this needs to be greater than or equal to this. Okay, go on to the last problem. We've got these companies. And I'm going to, first of all, I'm going to copy this entire thing down to here, like that. And then I'm going to get rid of all these. And, oops, that's not true. So all of these, I'm going to change that to just a number. File number, and show it as a whole number. There. Now these are going to represent, did I choose that route or not? So these are going to be 1s and 0s. These will be 1s and 0s. So if that's 1, that means that company 1 chose that route. So my total cost is the sum product of the cost of the route against did I choose that route for that company combination. And I'm going to try to take that and make it as small as possible. And a couple things is that, now remember, these are going to be 0s and 1s. I could go replace them right now and make them 0s or 1s, but a solver will do it for me for free. And what I want to know, this is the sum of all these. And this is the sum of all these. Like that. So the sum of these, this is the routes that company 1 is selected. The sum of these have to be 2. So I'm going to put right there, 2. And then this has to be exactly equal to 1. Route 1 is going to be assigned to exactly one company. So I'm going to write a constraint that says that this number needs to be equal to this, and copy it for every one of these, and that these numbers need to be less than or equal to this for all of these. There's my total cost. The trick is I've got to choose these variables. I've got to choose these variables here so that those are the decision variables. And there's two ways to do that. One of them is the old fact. This is the one way. I'll go ahead and do it. I'm going to take this cell. What I'm trying to do is take that. I'm trying to minimize by changing, and this is the pain. This one, all of these, there you go. That's what Excel has control over. Then I'm going to add a series of constraints to say all of these need to be less than or equal to 2. And all of these need to be exactly equal to 1. Like that. It's a linear model. And I can solve it. There you go. So it starts choosing. So you can see company 1 got route 3. Company 2 got route 6 and 7. And there's your best answer, and that's it. That's one way to do it, and that works. The other way to do it is I could go back, rather than doing my decision variables that way, I could go back here, and I'm going to go back and I'm going to do a find and replace. I'm going to find in this area, I'm going to replace it with a really, really big number. So these are in the thousands. I've just replaced it with a 99,000 number and replace all. So now these are going to be very expensive arcs. So company 1 will never want to go to route 1 because it's real expensive. Now I could go back and I could, now that I've got that, I could go back to my solver, and rather than doing this mess, I could go grab all of these like that. So all of these variables, but it won't choose these that have a 999 because it's expensive if it doesn't have to. So gets the same number. It's a little faster. I did a replacement with all of the blanks. I made them very cost prohibitive by making them very expensive. Okay, that's the 3 solutions, and if you got any questions, let me know. Thanks.